Thank you, Velu. Today, I'd like to share my knowledge on VoIP concept. Agenda goes like what is voice over internet protocol and flavors of VoIP and how it works and factors affecting voice quality and parameters of cost, quality of service, and finally queries. First, we go to what is VoIP. Yeah, VoIP is nothing but voice over internet protocol. So we can call that one as voice over broadband or voice over internet. Yeah. Then actually, what is VoIP? Your voice, analog voice, will be converted into digital. Then it will be compressed into packets. Then it will be carried over network internet protocol. Then it will be to the destination end. Again, it will be decompressed and depacketized. Again, it will be converted into analog voice and it will be reaching to the destination end. So your voice is converting into digital and it's reaching to the destination end. So if you take in this diagram, here your voice, this is analog voice. So here in this diagram, this is a personal computer PC which is connected to the internet through the cable modem, and here this is a telephone, normal telephone, which is connected to the internet through phone adapter, ATA, analog telephone adapter, and this is receiving side, again same, likewise. If you see flavors of VoIP, yeah, we have three types: ATA, IP phones, and PCs, PC to PC. If you see ATA, analog telephone adapter, which is most common and simplest method. And ATA means analog telephone adapter, which converts your voice signals into digital signal, and it will be connecting your normal telephone cable to the internet with the help of ATA. If you see in this diagram, here this shows normal telephone which is connected to internet through the IP converter is nothing but ATA. So this is from here to here. This is phone cable, nothing but copper cable, and this is IP connection like Ethernet cable. Then second one, IP phones. This IP phones, we can say this is an example of IP phone. This is just looks like our normal telephone, and it will be having RJ45 Ethernet connector instead of RJ11 connector. Our normal phones will be having RJ11 connector. Yeah. In this diagram, here this is IP phone which is connected to your telecom service provider. From there, it's connected to your internet service provider. From there, it's connected to IP network. Again, it is connected to other end party, ISP. Then telecom service provider. Again, your destination end. PC to PC. Actually, that is very cheapest method to connect to use VoIP service. So all you need is only computer and software which supports VoIP and sound, speakers, and high-speed internet connection. If you see in this,
sorry, the remote audience can't able to see the PPT. Yes.
okay. Okay. Here, this is PC. It's connected to your telecom provider. From there, it connected to the ISP. From there, IP network. Again, it back to connected to the ISP, your telecom service provider, back to PC. Where VoIP? Where we can use VoIP? We can use in home purpose, and small business purpose, medium business purpose, and large medium purpose. Depends upon the requirement of the customers or users. Why we need VoIP? Yes. If you take a normal telephone, if you are calling suppose calling party is calling the called party, then first it reaches to the local exchange. From there, it connected to the remote local exchange with the connecting with the switches, and finally it rings at the called party's end. Whenever called party answers your call, then circuit is opened between 2 points. So suppose you have conversation for 10 minutes, this duration you want this line for 10 minutes. Suppose user a calling party is sitting in Chennai and the called party is sitting in Mumbai. The distance between the two parties is 1000 kilometers. Then this 1000 kilometers wire you want for 10 minutes. This is why you are paying more charges in case of normal telephone. But in case of VoIP, see, whenever your packets, your voice is packetized, it will be carried over IP network with the available paths. That means whichever path is free, it will be routing to the destination end. There will be no pre-establishment path in case of VoIP. This is why we are paying less charges in case of VoIP. And also it is easier to upgrade. Being this is software, it is easier to upgrade and it saves money as well. And also your voice and data can be carried over a same line. And also multiple devices can be connected together. Like multiple devices means your voice, your video, your fax, like that. Multiple devices can be connected. Yeah, how VoIP works. So whenever IP phone receives one telephone number, first it will check whether this is IP soft phone number or physical hard phone number by contacting the VoIP company's call processor. IP soft phone, that means normal extension, IP soft phone in the sense, and physical hard phone in the sense, that is PST number. By contacting the VoIP call processor, it will check whether it is IP soft phone or hard phone number. Then if it is IP soft phone number, then it will acquire the IP address from within the exchange. Then if it is physical hard phone number, then this call will be routed to the nearest gateway. That means local exchange. Then in case of IP, whenever you are speaking, then only data will be sent. So that I will show in this feature slide. So IP address to phone number. We all know that IP network deals with only IP address. Being we are using telephone number, we can't communicate by using this telephone number in the IP network. So our telephone number should be converted into IP address. This will be taken care by soft switch. This soft switch, what it will do, it will be having all information of users which are within its range, and also it will be having phone numbers of their users, and also it will be having IP addresses assigned for that particular user. We can say telephone number can be MAC address, and it will be assigning based on the telephone address, it will be assigning IP address. Yeah, here in this diagram you can see this is a comparison between a normal phone and IP phone. If you see here, in normal phone, just for hi itself, how many times data has been sent to the destination end. So whenever you are in silence also, data is sending to the destination end in case of normal phone. If you take in case of IP phone, whenever you are speaking, then only data will be sent. Whenever you are silent, there will be no data sent. So we can say there will be no redundant data in case of VoIP, and also it saves bandwidth as well. Okay, clear? Yeah, encoding. Yeah, we know encoding, coder and decoder. Coder means which converts your analog signal into digital signal, right? And decoder means which converts back to analog signal. Okay. Okay. So the encoding technology should be agreed by both source and destination. So whenever you are speaking, your voice will be converted into slices, 30 millisecond slices. That is nothing but packet. Okay, that packet, for that packet, timestamp and sequence number will be giving, and it will be giving to the UDP packet to transfer over IP network to the destination end. Okay, whenever you are silent, then data will be sending for every 180 milliseconds. So we got 4 codec technologies for VoIP service which supports VoIP. So first one is G.711, which is having a bandwidth of, which gives bandwidth of 64 kbps, and conversion time will be 0.125 microseconds, and voice quality will be toll quality. Toll quality is nothing but, see, you are breaking your voice and sending your IP network to the destination end. In case of normal telephone, there will be no breakage of voice. So voice quality will be good in normal telephone, but with this codec technology, you will be getting voice quality which equals to the normal telephone. That's why toll quality. Next one is G.726, which will be giving bandwidth of 40, 30 to 24 kbps, and conversion time will be 0.125 microseconds. Sorry, milliseconds, and voice quality will be near toll quality. Then G.729 codec technology we got, which is having bandwidth of 8 kbps, and conversion time will be 10 milliseconds, and voice quality will be fair to good. And the last one is G.723.1, which is having a bandwidth of 6.3 kbps, and conversion time will be 30 milliseconds, and voice quality will be fair. So this G.711 codec technology will be good to which will be used in VoIP service. It gives less conversion time, and voice quality will be toll quality, which is equal to the normal telephone line. Yeah, protocol structures. See, we need a great deal of background processing in case of VoIP, and also we need some standardized set of protocols which are useful for establishing call, disconnecting the call, exchanges media capabilities, and also converting your telephone number into IP address. So we got protocols like H.323, SIP, RTP, RTCP, and RSVP, RTSP, UDP, and IDP, then IP finally. These protocols which supports VoIP service. Yeah. First, we will see about H.323 protocol. Okay, H.323 protocol defines procedures, protocols, and components which will be useful, which will be used to send your voice and multimedia communication over IP network. If you see in this diagram, this is H.323 application. Application can be anything like your voice or data or facts, and from here your application like suppose voice will be taken care by RAS protocol H.255 and H.245 and RTP protocols. It will be this your voice will be taken care by these protocols, and it will be handed over to the IP packet network. So here we will see what is RAS. RAS means register, admission, and status protocol. So whenever one user is requesting for IP address something like that, then it will be registering its phone number. This is RAS protocol, and H.245 means it tells which codec should be used for that particular application. In this H.255, it sets procedures and messages for voice signaling and RAS functionality. Voice signaling, sorry, not voice signaling, it's call signaling. Call signaling in the sense how to set up your call and managing call and tearing down your call. Then RTP, real-time transport protocol, which will be used to exchange your voice packets between source and destination. So this diagram is clear. Okay. If you see H.323 components, we got 4 components like terminals, MCU, and gatekeeper, gateway. If you see terminals are nothing but your end devices which can make calls and which can answer calls. So we can say terminals like your telephone, your computer, and your video phones. So communication between these devices can be speech, with telephone, speech, and computer data, and video phone means video communication, and MCU, multi-point control unit, which allows users to set up a conference call between these terminals, these 3 terminals like telephone, computer, and video phones. Then gatekeeper. Yeah. we can say gatekeeper as our PBX, private branch exchange, okay, which will be which will be installed within the premises. So main functionality of this gatekeeper are, it is a managing device which gives admission control and address translation. Admission control in the sense, suppose one user is requesting some IP address, then it will be registering that device with telephone number. So that is called, it will admission will be controlled by gatekeeper, and also address translation. So your phone number will be translated into the IP address, that will be taken care by gatekeeper too. Then it tells which user can make calls, and also it uses RAS process, as I told, register admission status process it will be using, and gateway. So gateway is nothing but, suppose if you are calling extension within premises, so it will be routing by your PBX, that is nothing but gatekeeper. If you are calling peer from your extension, if you are calling PST number, then it will be routed via gateway, we can say local exchange. So it acts as an interface between two networks. If you see in this diagram, this is gateway, that is gatekeeper. The H.225 RAS messages will be exchanged between gateways, gatekeeper and gateways. Here also same way, H.225 messages will be exchanged. So H.call setup and call control will be exchanged between gateways, which will be those two protocols are using TCP protocol. Then RTP will be exchanged between your phone lines. RTP uses UDP protocol. SIP, session initiation protocol. So whenever whenever calling party is dialing the called party's number, session should be opened between these two ends. This will be taken care by session initiation protocol, and this is the standard ratified by the Internet Engineering Task Force. It has 5 core functionalities, like it allows users to locate with each other within its zone, and also it invites users into session, and it exchanges media capabilities, and also it modifies the existing session, and also it disconnects the existing session. And SIP has 2 components, user agents and SIP servers. User agents are nothing but again like terminals, so which can make calls and which can answer calls. So user agents can be classified into 2 types, user agent client and user agent server. User agent client means which initiates SIP request, and as user agent client means which receives and responds to your SIP request. And SIP servers, we got 3 SIP servers. One is a proxy server, redirect server, registrar server. Proxy server is nothing but it acts as a both client and server, because if you see in this diagram, suppose user A wants to communicate with user B, then it request will be sent to the proxy server. Then that proxy server will be sending request to the user B. Again, response is coming to the proxy server. From there, it's coming to the user A. That's why it's called as a server and client. And redirect server. Suppose you have one number named 12, then you change number to 34. So whenever other user is calling 12 number, so you should get message that 12 number changed to 34. That will be taken care by redirect server. And registrar server, it is like database. It keeps information for all users within its zone, and it works with redirect server or proxy server. If you see in this example, this is SIP example. Suppose user A wants to communicate with user B, then first user A sends request to the proxy server that I want to communicate with user B. Then proxy server will be getting IP address from registrar server. This is registrar server. Okay, then registrar server is giving, I told a registrar server is database. So it will be having a phone numbers associated IP numbers, IP address. So from there IP address will be giving to the proxy server. Then proxy server will send request that to user B that user A wants to communicate with you. Then user B responds to that request, yes, I am ready to accept call. From there proxy server will be sending confirmation that user B is ready to accept your call. Once all sessions completed, then main session will be opened between user A and user B. Then your voice will be carried over RTP packets. So clear this is. Achieving the quality. Quality is main concern in any environment. So in on a quite underutilized network, so whenever switch receives the frames, it will be delivering without any delay. If it is network is congested, then obviously it can't deliver the package whenever it receives. So there will be some delay will be happening. So in traditionally this network congested will be handled by increasing the link bandwidth and switching hardware performance. But quality of service is the overall method which gives priority for your traffic. For voice traffic, we should give priority, because whenever you are browsing, whenever you searched for Google, then you can wait for 2 minutes, say, but you can't wait in case of voice. So you should get voice quality what is just exactly speaking without any delay. So we should maintain proper cost levels. Yeah, factors consideration are loss of packets. It goes like loss of packets, latency, jitter. Loss of packets. When our network is congested, when a packet is entering into the congested network, obviously packet will be dropped. So some amount of packets dropped means it can be acceptable and recoverable by the protocol like TCP, which is reliable and connection oriented protocol. But in case of UDP, it can't be recollected. So it should be having high speed internet connection in case of VoIP. So if you see in this diagram, your voice is broken into packets named 1 to 5. Those packets will be delivered over internet. Then at the receiving end, packets are in this one, packet 4 is missed. From there, remote location again reassembles those packets in same order. So 1 to 5. Here if you see, packet 4 is lost because of network congestion. Okay. Yeah, latency. Latency is nothing but the total delay from start to finish is called latency. Suppose if you are delivering one packet, it will be reaching with the some amount of delay. Why this delay has happened means, so it has to travel over wire, and also it has to travel with the router and switch. The router and switch has to perform their lookup tables, and also it has to travel along the path, geographically path. So obviously there will be delay happening. So if the total delay from start to finish is called latency. If latency is less than 150 milliseconds, then your voice quality will be good. If it is more than 500 milliseconds, then you can't accept that voice quality. If you see in this diagram, G.711 packets sent every 20 milliseconds. If you are using G.711 codec, your packets will be sent at every 20 milliseconds over internet. Then once it's reached to the receiving end, so it will buffer will be maintaining at the receiving end, and from that buffer, your packets will be sending to the destination end at every 20 milliseconds. Jitter. So some kind of audio applications require continuous delivery of data, continuous delivery of packets. So all packets don't receive at the same time. So there will be delay from packet to packet. So if I'm sending two packets, one packet is reached to the destination end within 10 milliseconds, and the other packet reached to the destination end within 20 milliseconds. The delay between two packets is called jitter. See, in this diagram, in this first one, there is no jitter because all packets are delivered with equal time interval. You see here, there is a jitter because there is time interval, time gap between packet delivery. So within same LAN means there will be no jitter because distance will be less, so packets will be delivered soon. Then achieving the cost policies. We got three cost policies: best effort delivery, integrated service model, differentiated service model. Best effort delivery. So whenever packets are coming, so in that same order, packets will be delivered to the destination end. That will be taken care by best effort delivery. That means if you take example, suppose fire truck is coming, so we should give way to that fire truck. So, but best effort delivery says, so that fire truck also has to follow the normal traffic rules. So there will be no priority. That means there will be no priority in the best effort delivery. All data should be taken care. All data should be delivered first come first out. In that way, integrated service model. In this, we can achieve cost by. In this model, we can achieve cost. We can approach the cost by initiating the resource reservation protocol. So, in this, if a source wants to send data to the destination end, then source initiates the resource reservation protocol. So, that resource reservation protocol reserves the path between source and destination. So, then source will be sending data to the destination end. So there will be a pre-established path. In case of differentiated service model, there will be no pre-establishment path. So whenever packet is coming to the router, paths are already made. So based on that, packets will be delivered to the destination end. So here, why call flow functionality of IP phones? Suppose user A wants to communicate with B, then call set of messages will be sending, then alerting messages will be sending by the user B, connecting message. Once he picks the user B picks the receiver, then connecting messages, then UDP packets will be exchanged between source and destination, then disconnect messages. If user A hangs the receiver, then disconnect messages will be sending, then release messages. Circuit is released. Features. Why got features like caller ID, call waiting, call transfer, and repeat dial, return call, three-way calling, and call forwarding. Here, caller ID means if someone is calling you, you can use the calling party's number in your display. Then call waiting, you know this thing. Call transfer, repeat dial, return call. Return call means suppose if you called one user, then user didn't answer your call, then this return call feature will be telling that you got call from this person and at this time. So then user B can see that one and call back to the calling parties. Three-way calling is nothing but setting up a conference call. Call forwarding means from one number to other number call forwarding. Way forward. Yeah. Using VoIP in India is legal, but using gateways within India is illegal. Why using gateways within India? Gateways within India is illegal means suppose you are getting call from USA. Suppose you should have +1 country code in that one. If you have gateway inside India, then you will be getting with +91 country code because that gateway is within India. So obviously there will be less charges in that call for that call. That's why we shouldn't have, as per rules, we shouldn't have gateway within India. And also you can make calls to the remote users, but you can't make calls, VoIP calls within India. But try given permission for some MNCs to use VoIP service. VoIP service in the sense from phone to phone you can make, but in for residential purpose like that you can't use VoIP service from phone to phone. But you can use PC to PC flavor, as I discussed earlier.
UK number.
Queries.
Can you repeat that last statement which you talks about illegal say, right?
Yes.
VoIP gateway.
Yes.
Yeah.
You can, using VoIP in India is legal only, but having gateway, when you will be using gateway means if you are dialing one PST number from your VoIP, your IP phone, then it should routed through the gateway. Suppose you are calling, if you are getting call from USA to India, so they are calling your PST number, you should come through the gateway. If it is you are having gateway within India, then you will be getting with country code +91, okay, instead of +1. So if it is a gateway